Hi, my name is Madelaine, and I'm studying water and chemical mixing in estuary seabeds. I'm starting my project by modeling groundwater movement in the Chesapeake Bay, the largest estuary in the United States. These models will show how surface water mixes with groundwater in the estuary. This has been well studied in rivers and streams, but not in estuary environments where freshwater meets saltwater through alternating tidal currents. Surface water in estuaries tend to be highly polluted, particularly with nutrient pollution. The Chesapeake Bay has a vast watershed spanning 6 states and emptying 300 million tons of excess nutrients into the estuary every year. These nutrients come from fertilizer from farming, industrial emissions, and sewage from urban environments. The estuary cannot use all these nutrients, and this excess can cause algal blooms, which are toxic to humans and animals, and cause water quality advisories, beach closures, and even result in the death of many aquatic and marine organisms. These water quality issues are one part of why we need better computer models to understand impacts of nutrient pollution to local ecosystems and economies such as fishing and tourism. We first need to understand what usually happens to nutrients in our ecosystems. Rivers normally absorb nutrients through the mixing of surface and groundwater in riverbed sediments in this location here called the hyporheic zone. One way this mixing happens is because of the physical structure of riverbed sediments. To see how this happens, we'll take a look at this cross-section here. As water flows in one direction, water pressure drives surface water into the sediments, where it meets upwelling groundwater to create a zone of important chemical reactions, which can help remove excess nutrients like nitrogen before the chemically modified water exits the sediments and returns to the surface water. However, in estuaries where freshwater meets saltwater, these dynamics are not well understood and modeling them is difficult because in estuaries we have surface water with alternating currents due to tides and varying levels of surface water salinity mixing with fresh groundwater. My computational models of sediment structures will take these complex dynamics into account, and by modeling the seabed, we can see how mixing dynamics occur under the sediments. This simple test model shows alternating levels of salinity from blue freshwater and yellow saltwater in a cross-section of one sediment structure. I've only just begun my research, but we hope that this model will help us better understand and predict the distribution of nutrient pollution in the Chesapeake, which will hopefully lead to smarter guidelines for managing watershed development.